Hello everyone, in this video we are going to discuss about the organic chemistry. Before that we need to discuss the importance of organic chemistry. Organic chemistry is a branch of chemistry that deals with carbon compounds, and these are mainly the natural compounds which includes carbohydrates, proteins, vitamins, nucleic acids, etc. These are usually present in the human body and also the living things. In order to understand the chemistry of living and non-living things, we need to study about these biomolecules. And if you think the main application of this organic chemistry is nothing but designing drugs. Now we will discuss about the carbon. Carbon is an element which is placed in the 14th group and second period in the periodic table. The atomic number of carbon is 6. The number of negatively charged electrons are 6 and the number of positively charged protons are 6. By the presence of equal number of electrons and protons will neutralize the molecule. The electronic configuration of carbon is 1s2, 2s2 and 2p2. With the help of electronic configuration, we can predict the number of valence electrons, that is nothing but 4. The number of valence electrons are nothing but the number of electrons that are present in the outermost shell. Here, in case of carbon, the outermost shell is second shell. There are 2 electrons in s orbital and 2 electrons in p orbital. In grand total, there are 4 number of valence electrons. Now we should think about the type of bond that is present in the carbon compounds. Every atom tries to get stable noble gas configuration in their valence shell. But here carbon is having 4 valence electrons. In order to attain stable electronic configuration, it will share electrons with other atoms through covalent bonding as it cannot form ionic bond. But there are some exceptions where carbocations can form ionic bonds. Why am I giving a statement that carbon cannot form an ionic bond? Here is my reason. So, to form an ionic bond, there should be a large electronegativity difference between the two atoms to attract the electrons and form ions. But here, the carbon electronegativity is not high enough to strongly attract electrons from other atoms, so it cannot form ionic bond. Instead, it will form covalent bonds. Next, we need to discuss about the hybridization. Hybridization is a process of intermixing of atomic orbitals with the same energy levels to give the same number of a new type of hybrid orbitals. Here, the atomic orbitals are converting into the hybrid orbitals. There are 3 types of hybridizations in carbon compounds. There are sp3 hybridization, sp2 and sp hybridization. Now, let's discuss about the sp3 hybridization. sp3 hybridization is nothing but the formation of 4 hybrid orbitals by mixing one s orbital and 3 p orbitals. For example, here we take methane molecules, CH4. In methane molecule, one carbon atom forms 4 sigma bonds with 4 hydrogen atoms. The geometry of the methane molecule is tetrahedral and the bond angle, that is, the distance between two bonds is 109 degrees. Now we move towards sp2 hybridization. In this, the 3 hybrid orbitals are formed by mixing of one s orbital and 2 p orbitals. Here, let's take an example of ethene molecule. Each carbon atom forms 3 sigma bonds with 2 hydrogen atoms and one with other carbon atom, and one pi bond is formed between the 2 carbon atoms. And the geometry of the molecule is trigonal planar and the bond angle is 120 degrees. And the last one is sp hybridization. Here, the 2 hybrid orbitals are formed by mixing of one s orbital and one p orbital. Here in this case, we can take an example of ethane molecule, which is nothing but CH triple bond CH. In ethane molecule, each carbon atom forms one sigma bond with hydrogen atom and one sigma bond with other carbon atom, and 2 pi bonds are formed between 2 carbon atoms. The molecule is in linear shape and the bond angle is 180 degrees. Thank you.